Now, having just suffered through section 3.5, naming ionic compounds, this is going to seem so much less painful in comparison, I promise. Here we are going to talk about naming molecular compounds. Um, Now, when we talk about molecular compounds, what we're talking about is covalent, meaning electron sharing, non-polyatomic ion, okay, so those have their own naming rules we talked about in 3.5, so we're not talking about carbonate or nitrate or nitrite, but covalent compounds that are not polyatomic ions. Now, because these don't follow any set of naming rules or combination rules such as +2 ions combining with -2 ions in 1-to-1 ratio and that sort of thing, we literally have to spell out exactly how many there are of each of the different portions of the molecule. And we do that again with Greek prefixes, just like the hydrates. For the first element in a name, we give the prefix, with the exception of mono. We don't say mono for the first element, and we just give the element name. So if we have N2O, for instance, we'd name this as dinitrogen. And then we get to the second part here. The second element, we give the prefix, and here we do say mono if we need to, and the element's root, and then change the ending to "ide." So it's kind of like pretending this is an anion, even though we know there's no ionic nature to a covalent compound. So again, with N2O, we name the second part of this monoxide. So monoxide. A lot of times you'll drop a double vowel. Sometimes you don't, sometimes you do. Give it your best shot and just try and learn from experience of seeing and hearing the molecules, of seeing them correct. I am not going to give you a test where you have to decide whether or not it's monoxide or monoxide. Either one, as we're learning this, will be sufficient. So the two together, N2O, would be dinitrogen monoxide. That's as hard as this is. That's as bad as it gets. Okay? So give it some practice. Pause it, write these all in, see what you think, and go from there. So here's the answers once you have unpaused it. Carbon monoxide, carbon dioxide, sulfur dioxide, dinitrogen, tetroxide. So tetroxide could be tetraoxide. I'm going to go with tetroxide. Phosphorus. Pentachloride. And tetraphosphorus. Octoxide. And carbon tetrachloride. Chloride, yes. And nitrogen triiodide. Iodide. There you go. The next thing that we learn is how to name acids. Yep, that was all covalent compounds. And by the way, covalent compounds, how do we know it's covalent or molecular? And that we follow those set of naming rules and not the ionic? Two things from the right side of the periodic table. When those get together, a nonmetal and another nonmetal, then we know that it's a covalent molecule and that we name it with those di-tri prefix type molecules. Naming system. So for acids, though, how do we know it's an acid? Well, it starts with one or more H plus cations. So we can have HCl as an acid, HF is an acid, H2S is an acid, and there you go. So how do we name them? If we have a binary acid, meaning that the anion is not polyatomic, then all we have to do is change the hydrogen cation to hydro. So if we have HCl, we name the hydrogen hydro. And that's a prefix. So we're going to toss the anion's name all as one total name with this hydro. We name the anion just like we were going to start naming it as an anion. So we get the root of the name. So chlor. But we change that IDE ending from the anion to ic because it's an acid. And then, just for good measure, we throw the word acid in at the end so nobody can be surprised that it's an acid. So this would be hydrochloric acid, HCl. So give these a shot. Pause, practice, give it a shot, see what you get. And now you're back. We just did this one. So hydrochloric acid, hydroiodic acid, hydrosulfuric acid, hydrobromic acid, bromic, and hydrophosphoric, and hydrofluoric. Yes, I do mispronounce fluorine. So I can remember to spell it with a U-O instead of O-U. Hydrofluoric acid. Voila. If you have an oxoacid, which just means that there is a polyatomic anion with oxygen in it, we differentiate that from the binary acids we just named by saying, or actually by not saying, anything about the hydrogen cation at all. Okay? This lets us know that there's a polyatomic ion present. When we name the anion, we have to change the ending based on what the anion is, so that people can know whether it's the lower number of oxygen or the higher number of oxygen version. So if we have an acid with the chlor 8 anion, we will change this to no mention of the name hydrogen in here. Chlor 8 goes to chloric, and then the word acid at the end, as always, for good measure. So with H2SO4, we don't mention the hydrogen at all. Sulfate becomes sulfuric acid. Okay, and H2SO3 would be sulfurous acid. So sulfate, sulfuric, sulfite, sulfurous, etc. Okay, so here's some of these for practice. So go ahead and pause, give it a shot, and you're back. So chloric acid, nitric acid, nitrous acid, sulfuric acid, and perchloric acid. Good. So let's throw a few of them in together, practice it, see what you get. This kind of draws attention to the similarities and the differences. Nitrous acid, hydrofluoric acid. FO minus is the hypofluorite ion. So I say hypofluor. So hypofluorite ion, acid. Same thing here. Hypoiodite would be hypoiode, or the acid, and the word acid. Excellent. So there and back again, right? So what if we're going to translate these names of these things? So we can have nitrogen tetroxide. It's very easy for the covalence, isn't it? Dinitrogen and 2 tetroxide. O4. That's it. Sulfur trioxide. Sulfur. There's no mono, so it's just 1 trioxide, 3 oxygens. Easy. Hydrosulfuric acid. Hydro, H. Hydro means this is not polyatomic. S is minus 2. H is plus 1. So therefore, 2 of these. That's hydrosulfuric acid. Just sulfuric acid. It's the word acid, so I know it starts with H. Sulfuric without a hydro, so I know it's polyatomic. Ic means this is the sulfate ion. So sulfate is SO4. Whole thing's minus 2 because we've memorized that. H pluses are plus 1. So H2SO4 is sulfuric acid. Okay, so pause it, give it a shot. And we're back. HF for bromic, HBrO4, acetic, HC2H3O2, hydrophosphoric, hydro meaning not polyatomic, minus 3 for phosphorus means 3 hydrogens, phosphorus, okay, so it is polyatomic, it's the PO3 minus 3, that's phosphite, so 3 because that's minus 3, hydroiodic, HI, hypochlorous would be HClO because it's the hypochlorite ion. So hypochlorous acid right there. Hydroselenic, so hydrogen selenide. That's minus 2, so that's H2Se. And cyanic. There's no hydro, but it's an acid of the cyanide ion. There we go. Voila.